Hello, my viewers. My name is remaining young Grace Sunday, and I welcome you all to my channel on PU Formal Academy, the academy that work with my own professional experience in the industry. In my presentation today, we shall be looking at knowing the TDI index consumption constant in the formulation. I can still recall someone asked me a question. He said, "Oh, well done, sir. But I want to know how do you get 9.67 in calculating an index and a 0.155 value in that uh, formula in calculating the index." So now, so okay, I will release a video on this, and this is the video I'm going to release now. Looking at this formula, this is 87. Remember, entire bracket affect this. So 174 is the molecular grams per mole of TDI. Okay, looking at toluene diisocyanate. So it has two isomers, 2,4 and 2,6. So when you divide this by 2, okay, you have this. You have 87. Now, in respect to the 100 of polyol, the molecular mass of KOH, this is potassium hydroxide, is one of the key reagents that are being used when you are trying to carry out a titrimetry analysis of how to determine hydroxyl group of sample of polyol in 1,000 grams of the sample. You understand? So you use KOH. So that in respect to 1,000 will give you this. You understand? And this is the OH value. That's all. Now looking at water. Water has a gram per mole of 18 in the total. This is hydrogen 1, 2 oxygen. This time 2 plus this 16 plus that 18 plus that you have 18. Now you have 18 divided by 2. Water has 2 active hydrogen that can easily donate it in an acid-base reaction. So when you divide it by 2, you have this 9. Now, taking this into multiplication, if you want to open this bracket now, what you have is that 87 times 100 divided by 561,000 will give you 0.155, okay, times the OH group, that is it, and then plus, okay, let me go to this, okay. Now this one will also be the same. So this times weight of that water, okay. So in this case, we'll be having a 87 divided by 9, okay, times you have that. So when you have this by this, you'll be having a 9.67. So in this case, if we rearrange this equation, the total of this will give us, okay, can I clean this? Permit me to clean this. I will say rewrite it. So when we do this to this, we have 0.155, okay, times 0.8 plus this time this will give you 9.67 times that of water, that is the pph of water, times 100. So that will give you the TDI. Is therefore mean this is the amount that is reacting with water. This is the amount that is reacting with a polyol. So for example now, 0.155 times, assuming that the hydroxyl value of polyol is 42, you put your 42 here, plus 9.67 times part per 100 of water, assuming it's 4.2, is this. So whatever you multiply here, assuming the total of this give us 58, okay. then times the TDI times the index of that your TDI, maybe 112 all over 100. So this will give you 58 times 1.12. So whatever you multiply here, let's assume you have 61. Therefore, this is your index. For example, I'm not using calculator. It's just an example. So whatever you are added is it. So this 9.2 is as a result of multiplying the total derived from the total molecular weight of TDI, okay, divided by 2 of the isomers times that of water equivalent divided by 9. This is 9 gram per equivalent. Into this, you have that. So this is how the figure was properly derived, okay, from the molecular weight of TDI and that of water. Is that not interesting? I hope you understand. So continue to share, like my page, on your notification bell so that whenever I upload a new video, you'll be notified. Thank you, my viewers. Bye bye.